another USB charger from the dollar store of all places. Yes, it is. Normally I wouldn't be bothered having grabbed this, but just happened to catch my attention here. It's marked Intertek. So take a look at this thing and see if maybe this one will possibly not kill me. Maybe it'll just seriously injure me if it fails, or maim me. I don't know. Well, let's open it up, give it a full set of tests, and see. It claims, what, 1 amp? Yeah, 5 volt, 1 amp. So let's see how well it works. Alright, so fairly, typical setup here. We're going to have the USB adapter plugged in here, coming out with this, nice and, well, for USB anyways, this nice and heavy wire. Coming out from the power and into this current sink. And then I'm going to measure off of here with the oscilloscope probe, so yeah, it might be some noise being picked up by, from the nice antenna just sticking out there. Alright, so here it is plugged in, and I'm just going to go ahead and flick on this current sink right to about 1 amp. So turned it on, that's about a 1 amp load there, so you can see a slight dip in the voltage and quite a bit of noise. So let's zoom in and take a closer look at that noise. So I'll just pause that, and it seems to be pretty typical. This is what we're looking at for noise. So peak to peak of 848 millivolts, so not particularly great. 41.5 kilohertz frequency. And also, just for comparison, since it is unshielded wires coming out their power leads, there's the noise with everything still hooked up, but the current sink turned off. And actually, I'll just unplug that as well. And yeah, you can see that's just the noise being picked up from the lights. It looks like it's a 2-piece. Hopefully I can pry that apart. It's maybe been glued. I don't think it's, it looks pretty loose though. I don't think it's been sonic welded, so it's probably just, some sort of glue that was put in there. Possibly a flange with a clip. Alright, well that was really easy to get in. I just pried took a small screwdriver and just sort of pried it in the middle here of all 4 sides. And once I did that, when I got to the last side, which happened to be the bottom side when you're looking at the label, so I started here, just went around, then when I got to this side and I got the glue to release, I just gave a little pry and it popped right out. And there we go. It looks like pretty standard 2-layer construction here. So I'll have to get in there and we'll take a closer look now. Alright, so the first thing I notice here is they just put a little piece of tape there. I mean, it's not even sticking over top of the mains leads coming in. Solder looks pretty piss poor. Hopefully that's going to show up in the video, but it's very dull, typical low quality Chinese soldering job. So the wires come in. This actually is really nice. That feels like silicone insulation there on these wires. So yeah, I mean, I don't know. Again, spring for nice money on decent sized wire and with nice insulation, but they couldn't get the solder, I guess. Anyways, leads both come in here and straight into a small bridge rectifier, so no fuse at all. A little bit more concerning with this over some of the crappy garbage one, because this actually has decent sized leads here. I mean, these are still pretty small, and I mean, if something went horribly wrong and there was a dead short, like in that bridge, you'd blow the crap out of those leads, but you're going to get a lot more current flow possible through that compared to these little tiny wires that you quite often see. So no input protection coming in. Out of our bridge rectifier into filter cap here, which is looking like is what 4.7 400 volt, 1 kilovolt rated cap there. Usually that's for suppression. You would have something like that, but I'm not really sure what the heck they're doing working that, because you can see the transformer here. They've got the 2 leads coming out and going right to this other board, so there is no actual feedback. Well, no feedback directly. So I'm guessing that this transformer here has got, well, it must have a feedback winding on it coming back. There's your controller. Alright, so I wasn't able to find the part number for that switcher chip at all, but as I started to trace the circuit back, I realized that it looked really familiar. And I actually have a a switcher chip. I was thinking about building my my own switch mode supply, and it looks really similar to the data sheet. Unfortunately, my computer's down right now that would have that data sheet on it, and I can't find the chip to get the part number off of it either. But from what I remember, you know, this looks really similar. And so what they're doing is you got your, you know, AC comes in, it's rectified. We've got our high voltage DC here, and then we've got our transformer there. And so the transformer comes in, and you've got 2 pins and 2 pins. They're attached together, and that's your MOSFET. The switching element is is built in here. So we've got a, I think that's 2.2 ohm resistor there. Sense resistor. You've got your ground attached up here, so this has internally, it takes off of there and goes into an op amp, you know, to compare, and shuts down for overcurrent. Will shut off for the rest of that cycle if that occurs. And basically what they've done is you've got the secondary coil coming out here, and they've got it attached, well, tied into the ground for the primary, and then just a single diode, so half bridge rectified coming out here. There's a small cap there. It's only rated 50 volts. And what that's doing is it's just setting up for power supply. There's a voltage divider in here. And then this cap here is, can't remember if that's to set the oscillator speed or was for some sort of filter or something like that. I'm just trying to go off memory here. So basically what they're doing is they're using the power to power the chip here, and then there's a large value. It's a 2 meg ohm resistor coming from the positive high voltage side in here to the positive of the chip's power. So that basically will bleed enough power through to build up enough charge in this cap. And these switcher chips, what they do is they will actually sit there and not operate on a low voltage even when it starts to come up. They'll stay in a shutdown state until they hit a certain threshold that's higher than the minimum voltage that they need to keep operating. So that way it'll start to operate off the energy stored in this in the capacitor here, and then that'll get it up and running, and then it can supply its own power. So basically that's what they're doing, and that's why there's no no feedback, like no opto coupler needed this way. So then what they're doing is they've simply wound a secondary coil around this transformer. So there's 3 coils. You got your primary, and then you've got 2 secondary coils. And so the other one comes out, and again, they're just using the half bridge rectifier. I find it interesting how there's a cut in this trace here. Like, they actually bring the trace over to the filter cap and then there's this resistor here, which I thought was a little odd at first that they put a bleed resistor in, but because there's no feedback off of this, my understanding is that you need to have a certain minimum load when you do that, or otherwise you're, because it was in the data sheet for the switcher chip that I had to do, not to do something like this, they didn't have it tied in. They were you know, doing optical, had opto isolators to come back, but they had an example with 2 outputs, and so you regulated one, and then the other one you could have at another voltage if you wanted. In the example, they did say that you did have to either had to put a load resistor across or do something to ensure that there was a minimum load. So other than that, that is about it. I mean, we've got our 2 resistor dividers here connected to the 2 data pins on the USB. So I put it back together here, and just a few things that I forgot to make note of while I was pulling it apart. I sort of popped it out quickly. So the output board here, you know, it's got these nice little grooves here, and it fits in these slots, so it fits in there, you know, nicely, and it's somewhat secure, you know, up and down this way. Well, I guess it can't go too far because once you put this on, that sandwiches it. The primary board, however, just sort of floats around in there. It's a shame they didn't go to the same effort of detail, but they did put these 2 right here and here, these 2 pieces on, so that, you know, when it comes right down to it, it can't push down. Not that the transformer would let it anyways, but it would have been nice if they'd had something to just maybe hold it up a bit, just to provide some more isolation in there. So, you know, it's not particularly great, not the worst I've seen. It's definitely a lot better than you know, some of those others that I've seen. I mean, it's not held together particularly well, and the lack of input protection is kind of concerning. You know, there should be, if they'd put some sort of a fusible, you know, maybe a fusible resistor or something just to protect the input, and something a little bit better maybe to protect those other than this little piece of tape that was on there. I mean, piece of tape like that, and, you know, jam that in there, and you know, a couple drops of glue, and that's it. So definitely a step up. I would, in a pinch, I guess I would possibly use one of these, being very cautious with plugging it in, because if anything goes wrong and it was to be shorted out, plugging it in, it may want to explode in your hand. Alright, well, that's it for this video. Till next time.